Hi, in today's video we will be discussing the k-nearest neighbor algorithm for classification and regression analysis. We'll be discussing what the algorithm is and how it works, different methods of calculating the distance between points, which we'll get to in a few minutes, and how to choose the k-factor, and we will also be taking up a few examples in Python and R. So, k-nearest neighbor is non-parametric and a lazy learning algorithm. What is lazy learning? It means that you don't need any training data points for model generation. It all happens in the testing phase, which makes the testing phase much slower and costlier. What is non-parametric? It means that your data distribution does not need to be a bell curve or normal distribution. The k-nearest neighbor algorithm is a very simple algorithm that classifies your data points into different classes based on the similarity measure. It's a supervised learning algorithm that is used for both classification and regression techniques, but it is more popular for the classification problems. So in the k-nearest neighbor classification, the output data is put into various classes, and the number of classes is determined by the programming. The k-nearest neighbor classification is based on classifying your input data into output classes, and the number of classes, which here is called k, is determined by the elbow curve, which we will get to in some time, and the distance is also determined by using various distance algorithm. The most popular is the Euclidean distance, but we will also be discussing Manhattan distance and Hamming distance. So what the algorithm does is it calculates a distance between various points and sees which of the distances is nearest to a specific neighbor. And by nearest, it means that it should have the properties that are very similar to your neighbor. This is to your main point. This is similar to your set of friends that you choose in a class. So if you enter a class and you sit, you would always sit with friends, and if you decide to sit with friends, say, who have characteristics such as they like reading books and they like to play the piano and or any musical instrument, and another group of people in the class is people who play soccer, and the third group is people who are very artistic. So if you decide to stick with people who are very artistic, so it means that you are also somewhat an artistic person. So you would be classified into the third class, which would be the artistic people. So the algorithm also does something similar. If you have the characteristics of one class, you would be put into that class. How the distance is calculated, we use three different methods usually in the KNN algorithms. One is a Manhattan distance, the other is Euclidean distance, and then we have Hamming distance. Manhattan distance is the distance between the 2 points measured along axis at right angles in a plane with x at P1 and P2 and y at P2, Q2. It is P1 minus P2 plus Q1 minus Q2 and the absolute value of the differences. In the Euclidean distance, it's the shortest distance between the 2 points. So if we want to go from x to y, we just draw a straight line between those two. And the formula for that is under root of P1 minus P2 square plus Q1 minus Q2 square. The Hamming distance is used for categorical variables. It is a difference between two strings of identical length. So if the two binary strings of equal length are compared, the only the positions where the bits have changed, though that those positions are counted. The drawbacks of k nearest neighbor is the features have to be in a very standardized format. This means that the variable has to be rescaled to have a mean of 0 and a standard deviation of 1. And since all the training data is used in the testing phase, this makes the training faster and the testing phase really slower and quite costlier. The pros and cons of KNN is the KNN algorithm is very easy to implement. It is very good for very large sample of data, and it has a very adaptive behavior, and you can easily do parallel implementation. The KNN also has disadvantages, and it requires large storage area, and the computation is intensive, and it's highly susceptible to the curse of the dimensionality. KNN is used in several sectors such as finance to predict the rating of customers, in marketing to segment customers into different classes, in healthcare for microbiology gene classification, in political science to determine if the voters will vote or not, in handwriting detection, image recognition, video recognition, and pattern recognition. How to choose K? The best way to find the best value of K would be to plot a graph of various values of K against the validation errors. For K equal to 1, the model overfits on the training data, which leads to a high error rate on the validation set. And for a very high value of K, the model performs poorly on both training and validation sets. So we have to find the optimal value of K, and that is at the point where the validation produces the minimum error, and beyond that it again moves up in the graph. So the best would be in this area. It looks like it should be K equal to 9, and we call this the elbow curve because it has a shape of an elbow, and it is used to determine the K value. We will be now doing some examples on the KNN algorithm. I'll be using the iris data set and implement it in Python. Python already has some preloaded data sets, so I'll be using my iris data set from there. You can also download it from UCI machine learning repository. The data has about 150 records, and it has 4 columns and one target variable. The target variable is already available in class format. The first thing that I'll be doing is splitting the data into training and testing sets. I'll be keeping my training set as 2/3 and my test set as 1/3. Once I've split my data, I'll be implementing the classifier. I'll be initiating my classifier with K equal to 3, and then I'll be fitting my model with my training features and training targets. The next step would be to predict my data to see how my classifier did. Now to evaluate my model, I'll be using 2 matrices. One is the confusion matrix and the other would be the accuracy score. For the confusion matrix here, we see that all the true values are mentioned in the diagonal format, and all the bad values or the wrong values that came out from the model are in the edges of the model. Our model did not do 100% accurate, and we have one error, and the accuracy score of our model is 0.98 or 98%. Now, because we don't know the exact k value for which a classifier would do the best, we will be running the classifier on a range of values. I chose my range to be 1 to 26, and I'll be running for each value of this from this range and calculate the misclassification error. Misclassification error is 1 minus the accuracy score. I'll be storing that in the scores list. When I plot a simple line chart for this, this is what I get. The best way to find out what my best value of k is to use this statement, and the optimal number of neighbors is 11 in our case. Next, we will be implementing the iris dataset using the R scripting. We'll import the required classes, and once again the iris dataset is already available in R, so we'll just be using the available dataset. I used the random generators from 1 to 150 so that we can just randomize our dataset. I have used a normal function here because my data has to be normalized for the first two columns. You can skip this part if you have to. The next thing that I will be doing is splitting my data into training set and testing set. And after that, I'll be running my KNN model and running my table. Let's run the entire code and see how it works. So the model has been generated and we have the results here. My data did not do well. The diagonal here shows the good values that turned out, and the number 2 here shows that we had 2 false values. So the model did not do well. We can again run a loop in this, and for different values of k we can plot the graph and determine the best value of k. Once again it would be 11, I am guessing here. My entire code is available in GitHub in the data mining folder for KNN, and I have also implemented the code for the Python code for KNN regression. You can go through the code. See you next time.